Alrighty, in this final video for AP, we've got Gibbs free energy and the cell potential of a battery. Okay, so we already know that galvanic cells, I don't know why, we'll leave it GV, and electrolytic cells, galvanic cells have a negative delta G, and electrolytic have a positive delta G. We also know now from the last video that electrolytic cells have a positive cell potential, and galvanic have a, sorry, flip them, positive, negative. There we go. We know that a galvanic cell has a positive cell potential and a electrolytic has a negative cell potential. Okay, so we can combine this with our Gibbs free energy equations, and we can find that if we want to relate cell potential and delta G is equal to negative NF and the cell potential. Okay, now this N is the number of moles of electrons. F is the Faraday constant. And E is the cell potential. Okay, now the Faraday constant is a number, and it is 96,500, and that is coulombs per mole. Okay, coulombs per mole. All right. So delta G can be related to the cell potential. Now, if we look at this equation here, we see that if we have a positive cell potential, then we're going to have a negative delta G. If we have a negative cell potential, we are going to have a positive delta G. And that fits with our galvanic and electrolytic cells. Okay? Even further, we can relate this equation back to our equation for equilibrium. Now, if we set the delta G for these reactions are going to be equal, right? The delta G doesn't change whether or not you're looking at the cell potential or the equilibrium constant. So we have delta G is equal to what is it? RT, or negative RT times natural log of K. And then delta G is also equal to negative NF E cell. So if we set these two equal to each other, we get negative RT, I'll make that a little clearer, negative RT natural log of K is equal to the negative NF times the E cell. If we get the cell potential by itself, we end up getting RT over NF times the natural log of K is equal to the cell potential. So we now have two new equations, okay? Pardon me. We've got an equation relating the Gibbs free energy to the cell potential. And now, if we combine our Gibbs free energy equations here, we have a equation linking the equilibrium constant to the electrolytic cell. Now, if we have a reaction that is products favored, meaning our K is greater than 1, then we are going to have a positive cell potential, and that means it is a spontaneous reaction. Okay. Likewise, if we have a K less than 1, we're going to have a negative cell potential, and our delta G will be greater than 0. Okay? All this is coming full circle, okay? Talking about spontaneity and what am I trying to say? Equilibrium of these reactions. So, that is, I believe, yes, that is all for this video. It's a quick one, but it just introduces you to the equation here and the equation here. Okay, the Faraday constant is something to remember. Now, you may be considering or thinking, what sort of units are we getting on delta G if we have coulombs per mole in the Faraday constant? Well, the coulomb is a unit that is a combination of a couple different units. Sorry, I should say not the coulomb, but the volt, which is in the cell potential. So a volt is potential electrical energy. And so its unit can be comprised of joules per coulomb. Okay, if we're multiplying by coulombs and moles, then we're going to be getting rid of coulombs and moles, and we're left with joules. Okay. All right, I just wanted to clear that up. That is all for this video. Email me if you have any questions, let me know, and we will wrap up this semester cleanly. Okay? Have a good one.